Okay, a mole is not a furry critter that lives under the ground, although that is a mole, but a mole is our term that we use for a grouping of objects. A mole is not a little guy that lives under a bridge. That's a troll. A mole is a group of objects, like a dozen is equal to 12, or a pair is equal to 2. So you may be asking yourself, well, why do we use the word mole as a grouping? Well, I think it goes back to a Latin term. A mole means a bunch of stuff, basically, in Latin. And so it's a grouping of things. And in chemistry, a mole is equal to 6.02 times 10 to the 23rd objects, atoms, particles, formula units, just any quantity, just like a dozen is equal to anything that has 12 in it. So that is the number we use. And that's a really huge number. And we'll talk about the reason why here in a little bit, why that big number. A mole is sometimes referred to as Avogadro's number. This is in reference to an Italian scientist, Emilio Avogadro, and he was working on grouping things and doing chemical ratios, and it's a tribute to him and all the work that he did. And this number is so large because atoms are so small and numerous. And so if we just talked about atom ratios or particles or molecule ratios, these numbers that we would have to deal with would be huge. And so we group these in this mole bucket. Say 1 mole is equal to 6.02 times 10 to the 23rd objects. And that makes the numbers easier to deal with, these ratios easier to deal with, so we have smaller numbers to try to figure out. The number was chosen, that specific number was chosen because that's the number of atoms in exactly 12 grams of the carbon-12 isotope. So 12 grams of the carbon-12 isotope contains exactly 6.02 times 10 to the 23rd atoms. Of course, carbon makes up all of life forms, and so that particular substance was used because it's so vital in all that we do. So if you have 1 mole of carbon atoms, including all isotopes, it weighs 12.011 grams. We call this weight the molar mass. And you can find the molar mass on the periodic table. We've already talked about that when we talked about isotopes and how we calculate the molar mass from the weighted average of all the isotopes of the element. So if you look on the periodic table at carbon, carbon is atomic number 6 on the periodic table. It has 6 protons and 6 electrons in a neutral atom. And if you combine the weighted average of all the isotopes of carbon, carbon-12, carbon-14, etc., it would weigh 1 mole, or 6.02 times 10 to the 23rd atoms of carbon, would weigh exactly 12.011 grams. And so it would weigh a little bit more than carbon-12 because carbon has some heavier isotopes as well. But carbon-12 is the most dominant isotope because it's closest to the molar mass. So what does 1 mole of oxygen weigh, and how many atoms does it have? I'll let you think about that for a minute. Okay, so where would you find that? Well, you would find the weight on the periodic table, right? The non-whole number on the periodic table is usually underneath the symbol. And on my table, it actually rounds it to 16.00 grams. It's actually 15.998, something like that. The one I'm looking at now, the periodic table, says 16 grams. And how many atoms does it have? Well, 1 mole of anything has 6.02 times 10 to the 23rd. So it's just kind of like a dozen. If you had a dozen baseballs or a dozen basketballs, how many basketballs would you have? 12. How many baseballs would you have? 12. Would they weigh the same? No, they would not. the baseball and the basketball have different masses or weights. I usually give the example of bowling balls in baseballs. So if you had a dozen bowling balls, you'd have 12 bowling balls. If you had a dozen baseballs, well, you'd have 12 baseballs. But the bowling balls would weigh more than the baseballs. So the thing that's the same about a mole of anything is that they have the same number. The masses will be different for different elements on the table as well. Okay, so here we have 15.99 grams and 6.02 times 10 to the 23rd atoms. What does 6.02 times 10 to the 23rd atoms of phosphorus weigh? Okay, I'll let you think about that for a minute. You can look it up on the periodic table. It would weigh 30.973. You know, that's a big old long number. It must have a very precise scale to weigh something with that many decimals out, right? How many moles are in that? Well, 1 mole weighs that amount. We find that on the periodic table. I don't seem to be beating you over the head with this, but it's really important that you understand the concept. How many moles are in 28.80855 grams of silicon? 1 mole, which has 6.02 times 10 to the 23rd atoms of silicon. The atoms for 1 mole will always be the same. The weights will change.